Hello all, and welcome to yet another edition of Mr. Hargrove's math class, where today we're going to be talking about rational number types. And specifically what we're going to be doing today is talking about how to classify different types of rational numbers. So we're going to go ahead and jump into this lesson. As always, we want to start with the learning target. The learning target for today reads as such: students will extend previous knowledge of sets and subsets using a visual representation to describe relationships between sets of rational numbers. The success criteria, which again lets you know that you are on the correct path to success, reads as such: you will know that you are successful when you can define the following terms. And this is very critical. You need to be able to define natural number, whole numbers, integers, and rational numbers. And in addition to being able to define those words, given a number or a set of numbers, you need to be able to determine the classifications of the numbers using those vocabulary words. So if you know how to define those words, then you will know the numbers that fall within those categories. A big hint for the day: every number that you're going to see is a rational number. So before you proceed with this lesson, it's very important for you to make sure that you can differentiate between positive and negative numbers. Obviously, if the number has a negative sign, then that lets you know it's negative, and if not, then that means it's positive. And you also need to make sure that you know how to simplify a fraction, because you will encounter fractions that are not yet in their simplified form, and you need to be able to simplify it in order to classify the number correctly. So we're going to start off with some key vocabulary, and those vocabulary words are going to be the words that you need to know the definition of. So the first one we'll start with is natural numbers. So when you think of natural numbers, these numbers are also called counting numbers, because they are literally the numbers that we use to count. If I wanted to count the number of students in my class, I would start with, 1, 2, 3, and just continue so on and so on. If I wanted to count the number of people in a big crowd, obviously the number would be higher, but it's those numbers that you can literally count things with. All the way, infinity doesn't have an end. If you can count to it, then that is a natural number, okay? And also called a counting number. Whole numbers. Whole numbers are the exact same thing as natural numbers, but the only difference is we now add the zero. So that's the difference between natural numbers and whole numbers. It's just that one digit, which is why it's in bold. 0. So that, just keep that in mind. That is the only difference between natural numbers and whole numbers, is we add the number 0. When we move to integers, integers are all of the whole numbers plus their negative opposites. Now, I'm hoping you realize in here that these sets just build on top of each other. Okay, so the integers are all of the whole numbers, right? But it also includes the negative opposites of those whole numbers. So -3, -2, -1, 0, 1, 2, 3, and just continue on in either direction. Continue right, continue left. All of these numbers are integers on the number line. Now, rational numbers, again, the definitions build on one another. Rational numbers, every single number that we just spoke about is a rational number. So rational numbers include all of the integers, but they also include fractions and decimals. So if you look at the examples of what a rational number is, it's all the numbers that we've covered so far, but it also throws into account the decimals and the fractions, which is why you'll see them there in the examples. So if you look at this chart pretty much defines what you need to be able to do. Given a set of numbers, you need to be able to determine the best place for the number. So if I look at a number like 1/2, which is the first number you see top left, it's in the white section because that white section represents rational numbers. So that's a simplified fraction. And it's the same thing as 0.4 negative 3.4, 0.45, all of those are rational numbers that don't fit in any other category. Now, if I look at the blue section are the integers. Integers, remember, those are going to be the whole numbers plus their negative opposites. So negative 8 falls perfectly in the integers section because it doesn't fit in the whole numbers, okay? But if it fits in integers, it automatically is a rational number as well, because as you can see, all of these numbers that we're talking about fall under rational. And I already gave you that hint earlier. I'm going to give it to you again. All the numbers that we were going to talk about in this unit are rational numbers, okay? All of them are rational numbers, but your job from there is to determine, is it also, you know, integer, whole number? Does it also check that box as well? Is it also an integer, a whole number, a natural number? So, and then when you look at the orange section is going to be only the whole numbers. So obviously you'll see they have the 0 there because that's the only difference between whole numbers and natural numbers. And again, natural numbers, the green section, numbers that we use to count. So we can put this to practice now. We have the definitions at the top for your convenience. And the goal here is to be able to check the boxes that each of the numbers down in the table represent. So if I look at negative 3.7, well, what all categories does negative 3.7 fall under? Well, we know that they're all rational numbers, but I'm going to look to my right. Is it a natural number? Is negative 3.7 a natural number? Well, let's look up at the definition of a natural number. It says natural numbers are also called counting numbers because they are numbers that we use to count. Well, when we count items, do we ever count with negatives? No. Do we ever count with decimals when we're trying to count? We don't. So it's not a natural number. Whole number. It's not a whole number either because the definition of whole number are natural numbers plus 0. So it's not a whole number. Is it an integer? Well, integers do include negatives, but it only includes the negative opposites of whole numbers, okay? So the negative opposites of whole numbers. So since it's a decimal, it only fits in the rational number category. So I would put a check under rational only. Now let's look at negative 4. Well, is negative 4 a natural number? No. Is it a whole number? No, because natural or whole numbers cannot be negative. Is it an integer? Well, if I look at integer, the definition of an integer says all the whole numbers plus their negative opposites. So negative 4, because the opposite of negative 4 is a positive 4, I would say negative 4 is indeed an integer. And since it is an integer, by default, it is automatically a rational number because if you look at the definition of rational numbers, it says rational numbers are all of the integers plus fractions and decimals. Now, how about 250? Well, I'm going to ask myself again, is that a number that I can count to? Can I count to 250 just using my natural counting ability? Yes, I can. Since I can count to that number, any number that is a natural number is also a whole number. If it's a whole number, it's an integer, and if it is an integer, it's rational. So key point, if it's a natural number, it fits under all of the categories. Because if you go back to the chart, natural is inclusive of all of it. Okay. So, and then we can look at the fraction. The fraction 3/4. Well, is that a natural number? No, when we count, we don't count with fractions typically. It's not a whole number. It's not an integer, so 3/4 only falls under the rational number category. And what about 1.5? Pause the video, see if you can figure out where 1.5 goes. All the sections that 1.5 checks. Well, it's not a natural number, whole number, or an integer. 1.5 is rational only. Rational only. So now we're going to move on to some examples, but we want to do a little more work with some fractions. So Let's look at this, and I'm going to give you a hint. I want you looking to see, can the fraction be simplified? Because we always want our fractions to be in simplified form so that we can classify them properly. So let's go to the next set of examples. I'm going to leave the definitions of these words at the top, and we always want to reference the definition. So if I look at 20 over 4, another way to say 20 over 4 is 20 divided by 4, same thing. So 20 over 4, well, is that fraction simplified? And if I look, no, it's not, because both the numerator and the denominator are both divisible by 4. So that's how I know it's not simplified. So when I do 20 divided by 4, that equals 5. And now I can ask myself, well, is 5 a natural number? It is. And if it's natural, it's whole, it's integer, and it's rational. So now again, we want to look at the next one, negative 12 over 3. Well, is that simplified? And whenever I look, I see it's not, because both 12 and 3 are divisible by 3. Then I can simply just do that division. Negative 12 divided by 3, that actually is negative 4. Now, is negative 4 a natural number? No. Is it a whole number? No, because natural or whole numbers do not include negatives, but integers do. And remember, if it's an integer, it's automatically rational. Now let's look at 0. You should all know where 0 goes, because if you look at the definition of whole numbers says all the natural numbers plus the number 0. So those are all the categories that 0 falls under. And how about 5.8? Not natural, not whole, it's not an integer. 5.8 only falls under rational. And if we look at 9 over 4, that does not give me a natural number. It doesn't give me a whole. Doesn't quite give me an integer either. So that one's also a rational number. And like I told you, all of the numbers that we're dealing with are rational numbers. So you want to keep that in mind. I appreciate your attention today. As always, we're going to move on to some practice solving these problems. So look forward to doing that. Again, thank you for your attention, and we'll see you at the next edition of Mr. Hargrove's Math Class.